Hi, I'm Jocelyn Demelier, designer and developer of Through the Looking Glass, a tower defense strategy game that confines the player into a closed-off control room, where they must make use of CCTV feeds and a limited power supply to activate towers and stop creeps from invading. This project was built in Unreal Engine 5 and reflects intensive design research, object-oriented programming blueprint practice, and player-focused iteration guided by 2 rounds of playtesting. The game explores one key hypothesis. If players are given limited visibility and finite resources, then they will experience a heightened sense of anxiety and strategic urgency. This draws on Diane H. Sonnenwald's concept of the information horizon, which I learned through Keith Bergen's video where he applies it to game design to describe the balance between what a player knows and when they can know it. For example, fog of war in RTS games like StarCraft, a mechanic that hides unexplored or enemy-occupied areas of the map. It limits cognitive load while amplifying tension. I also integrated cognitive load theory from John Sweller, which examines how our limited working memory affects performance if it is overstrained. In my game, these ideas are embedded in how players must scan CCTV feeds and manage power under pressure from invading creeps, tasking players to make critical decisions with partial information. At the start of the project, I explored a wide range of strategy subgenres and identified 4 influential games that helped shape different elements of my design. Bloons Tower Defense informed my understanding of tight feedback loops and progression pacing, a textbook example of what Jesse Schell calls a satisfying feedback economy. Then, I looked at Five Nights at Freddy's, which showed me how fixed perspective surveillance can be used as a source of effective horror and tension, a concept well supported by aesthetics and the MDA theory. Faster Than Light gave me insight into resource-driven decision-making and the role of juggling strategic systems under pressure. What stood out most to me was how it uses a limited power pool to force players into a constant high-stakes trade-off. To help refine how I thought about player decisions, I looked at Tim Kane's video titled Player Agency. In it, Kane, one of the original creators behind Fallout, explains that agency only matters when a player's actions have clearly visible consequences. This resonated with how Faster Than Light gives immediate feedback when diverting power to shields or weapons, reinforcing what the players are not just absorbing in the game, but actively shaping in its events in real time. Lastly, Iron Lung showed me how UI and spatial limitations can deliver atmosphere and immersion, reinforcing my choice to set the entire game inside of one claustrophobic control room. Rather than mimicking any single game, I blended core mechanics and emotional tones from each to create a unique tower defense experience, centered around limited information and strategic urgency. The game is structured using the MDA framework by Hunick, LeBlanc, and Zubek. The mechanics of the game are centered around simple binary actions, pressing buttons to activate or deactivate systems. But these limited inputs give rise to 3 major dynamic systems. First, because power is finite, players must constantly choose which towers or CCTV feeds to prioritize. This creates moment-to-moment strategic power management system, where trade-offs are unavoidable, mirroring the real-time tension of games like Faster Than Light. Second, players must respond to enemy movement observed through fixed camera feeds. The timing and sequencing of their inputs becomes critical. This is the basis of the reactive combat system, where success depends on observation, anticipation, and fast, precise execution, mirroring the reactive horror of Five Nights at Freddy's. Third, progression is built through mastery. Players who learn to manage power effectively and activate towers in synergy are rewarded with in-game currency to upgrade their systems. This creates a dynamic of investment and improvement, a progression system that supports player expression and long-term planning, inspired by the simple yet addictive progression in Bloons. Together, these dynamics produce the aesthetics of Through the Looking Glass, a sense of strategic urgency, discovery through constrained vision, and eventual mastery through repetition and experimentation. There are 2 core game loops that structure how players engage with Through the Looking Glass. Loop 1, Reactive Combat. This is the moment-to-moment loop that keeps players on the edge and drives the core of the gameplay. Failing to act in time results in creeps reaching the control room and ending the game. This loop functions as a negative feedback loop. It challenges the player to respond to rising pressure in order to avoid loss. Loop 2, Progression. This long-term loop rewards mastery and incentivizes players to keep engaging with the system. As players eliminate creeps, they earn currency, which they can spend to upgrade towers or expand their power grid. Over time, players who consistently engage with and understand the game's mechanics are rewarded with greater efficiency, control, and strategic options. This loop acts as a positive feedback loop. Together, these loops echo the principles in Koster's A Theory of Fun for Game Design, where engagement is driven by learning, pattern recognition, and growing competence over time. The more the player understands the systems, the more expressive and confident they become, transforming initial stress into strategic empowerment. This was my first time using Unreal Engine, and I approached it through a constructive learning process. I prioritized documentation, then forums, then video tutorials when I was truly stuck. One exception was Matt Asplin's CCTV tutorial. His breakdown of the scene capture component helped me create a functioning surveillance system. In another tutorial, his door button interface logic introduced me to blueprint interfaces, a core technique I later applied across my tower and button systems. This single interaction model became a reusable architecture across my game. By tackling most systems through research and problem solving, I developed confidence and understanding, where I can now explain nearly all my blueprints clearly and adapt them for new context. These challenges taught me to break down complex problems, apply abstraction effectively, and value clean, modular design. My blueprint scripting reflects object-oriented programming principles, as described by Romero. I used encapsulation by keeping variables like power and health safely stored within actors. Through abstraction, I used interfaces like BPI control room to let systems communicate without being directly connected. Inheritance allowed me to build towers and creeps from parent classes, streamlining their shared functionality. Finally, polymorphism meant that different tower and creep types could respond to the same function calls in unique ways, a pattern that made my code much easier to expand and adapt. The following systems I'd like to highlight in my game present how I translated my high concept into functional gameplay. The entire game is played from a single claustrophobic room. Version 1 had controls spread across walls. Players found it confusing, which stopped them from engaging with the rest of the game. In my second version, I consolidated all the UI to one wall, added labels and feedback lights, and a minimap. Still, players struggled with orientation. This linked back to Sweller's theory of split attention. When players must mentally stitch together two unlinked sets of data like feed numbers and tower location, cognitive load spikes. I've now learned that the interface is crucial to guide attention more smoothly and improve gameplay all around. The room design remains one of the game's most important and challenging spaces. The power system limits player actions and forces constant trade-offs. Every time a player activates a tower or CCTV feed, it consumes 1 unit of power. If they deplete all their power, then they will be unable to activate more towers, unless they deactivate the ones they currently have on. However, as players progress through the game, they can earn and spend currency to expand their power pool, allowing them more flexibility and control over time. This echoes Tim Kane's view that player agency depends on feedback and consequences. In my game, every power decision leads to immediate and visible results, whether that means sacrificing vision to activate a weapon or allowing creeps to keep going for a bigger trap you have ready. These trade-offs create tension, but also give players a clear sense of control. In the project, I was able to conduct 2 rounds of structured playtesting, which revealed critical insights of the game. In my first test, players got stuck early, confused by unclear feedback and lacking understanding of power mechanics. All the interactions felt disconnected. In my second playtest, after layout changes and feedback systems were added, players improved their strategy but still reacted more than they planned. Long-term strategy was blocked by high cognitive load. These sessions reinforced Jesse Schell's idea that clear feedback loops are essential. This also confirmed Sweller's cognitive load theory. An overload interface can reduce enjoyment and block strategic thinking. This was only the second game I've ever made, and the very first video game I've ever made, and the first time using Unreal Engine at all. So the fact that I was able to build something playable and coherent at all is something I'm genuinely proud of. More than just building a game, I developed a systems thinking mindset that shaped the way I now approach design and problem solving. I learned how to use abstraction and interface calls confidently, ensuring that my blueprints were clean and modular. I also developed the ability to design systems that communicate clearly with one another, using interfaces and encapsulated logic. Most importantly, I learned that to trust iteration and player feedback as tools for refining both usability and gameplay. If I were to continue developing this project, my next steps would be to redesign the control room with a strong focus on user testing to identify and remove friction problems. I would also look to merge the CCTV and tower control into a more unified interface, simplifying player navigation. Adding visual cues like health bars, creep effects, and clear tower indicators would further support decision making as well. Finally, I'd improve camera navigation and feedback so that players always feel orientated and in control. These changes would all reduce cognitive load and help players engage more deeply with the core strategy systems of my game.